afternoon, teenagers. This is Mr. Williams. I'm going to try to very quickly solve two of the homework problems for you from the night book. So this is for AP Physics 2. And I will be doing problems number 16 and 17 on page 427. So number 16. Number 16 refers to this picture. What is the gas pressure inside the box? So the gas pressure inside this box. We have 16 centimeters here, 6 centimeters here. There's mercury here. There's gas inside the box and in this part of the tube. And there is air here. It's open to the outside air. Before I got distracted, I was drawing the picture, so I'm just going to put my little picture here. This is the gas, and the height of the mercury here is 16 centimeters. The height of the mercury here is 6 centimeters. So the difference in height between this and this side and this side is 10 centimeters, which is 0.1 meter. If this tube of mercury was not connected to the gas, if it was open on both ends, the liquid of the mercury would reach its own level, and there would be no D between them because they would be exactly the same height. Before I get started, I want to point out that you have atmospheric pressure pushing down this side, and you have the gas pressure pushing down this side. It's clear that the atmospheric pressure is greater because it pushed the mercury this far up. So that means the pressure of the gas inside has to be less than the atmospheric pressure. That's the conceptual part of this problem. Okay. Our formula is that the pressure of the gas plus the density of the mercury times the acceleration due to gravity times the height difference between the two edges is going to be equal to the pressure of the atmosphere. So if you solve that for the pressure of the gas, you're going to get the pressure of the gas is equal to the pressure of the atmosphere, not the atom, the atmosphere, minus the density of mercury times the acceleration due to gravity times the height. At this point, it's fairly easy to plug in. So the atmospheric pressure is going to be, let's see, what is the atmospheric pressure? It's going to be 1 atm, which is 1,300 pascals. So let's see here. That's 101,300 kilogram per meter cubed. No, per meter squared. Minus the density, which is 13,600 kilograms per meter cubed, times 9.8 meters per second squared, times the difference in height between the two, which is 0.1 meters. Let's see my calculator here. And I get that the pressure of the gas is 87,972 kilograms per. Why did I say kilometers? It is kilograms. Kilograms per meter squared. It's not kilograms per meter squared. Sorry. Atmospheric pressure is not kilograms per meter squared. It's newtons per meter squared. I'm just trying to rush and I'm getting in trouble. If you look at the units, you can see it works out because one of the meters crosses with one of these 3 meters down here, so you get meters squared in the bottom, and then another one cancels, so you get meters and just meters in the bottom. So kilogram meter per second squared per meter squared. That's the same as this. You can think about that if you need to. So this is pascals, is 87,972 pascals. That's the pressure of the gas. If you think about it, the atmospheric pressure is 101,300. So 101,300 is present down here, and only 87,927 is present down here. So you have a bigger force pushing here than you do here. So then the mercury gets shoved up. Hope that makes sense. Let's go to number 17. Number 17 shows this picture here. And the question asks, this container is filled with oil. It is open to the atmosphere on the left but not on the right. What is the pressure at point A? What is the pressure difference between point A and point B? And point A and point C? B and C are at the same height, so the difference in pressure between A and B and A and C should be the same difference, because the height difference is the same for both of them. So here's my picture. And C is here, and B is here, and A is here. Looks like A is at 50 centimeters, and B is at 0 centimeters, and C is at 0 centimeters. So you just move the decimal back 2 for each of them to make them meters. So part A says, what is the pressure at point A? So just like before, the pressure equation is that PA is going to be equal to P naught plus the density of the oil times the acceleration due to gravity times basically the change in the height. So that's going to be equal to 101,300 pascals plus the density is 900. If you look, this density is in a table in your book, so you should have looked that up. I showed it to you the other day, so you shouldn't have any trouble. It's just a couple pages back. 9.8 meters per second squared times 0.5 meters. If you multiply that all together, you're going to get 1.1 times 10 to the 5th pascals. So that is the pressure at A. Now the pressure difference at B, so that's going to be PA, final one. So it's going to be PB minus PA. And that's going to be equal to, so you're going to have two P's. There's going to be P naught plus rho G the distance to B minus T naught plus rho G and the distance to A. As you can see, well, this is the same in each, so we can rearrange this equation mathematically. We can pull out the common stuff. So it's the same as saying that, well, this is positive and this is negative. So positive atmosphere and negative atmosphere, that goes away. And then I have the same density and acceleration due to gravity for both. And we have the distance to B minus the distance to A. But the distance to B is 0. So that's just going to go away. So that goes to 0. Just like this and this add to 0. So then this is going to become the density due to gravity times this is going to be negative. Is it going to be negative? Let's see. Yeah, I guess. It depends on how you look. It depends on the comparison that you're doing, but this comparison would be negative times dA. So that is going to be the negative of 900 kilogram per meter cubed times 9.8 meters per second squared times that distance is 0.5 meters. So you're going to get negative 440 pascals if you're looking at B minus A. If you're looking at A minus B, it would be positive. So the pressure here is 440 pascals more than the pressure here. The pressure here is 440 pascals. Oh, I'm sorry, I'm not looking at the picture right. Let's think about what it means. The pressure at B is 440 pascals more than the pressure at A. The pressure at A is 440 pascals less than the pressure at B. So if you take the pressure at B and you subtract the pressure at A from it, you're gonna, it shouldn't be negative, it should be positive. I'm confused why it's negative. I think I made a mistake somewhere, but I'm not sure where I made the mistake. Oh, I honestly don't know where I made a mistake. This is 0 minus 50, so this should be negative. I'm not sure why I've got this negative here. I need to think about that more. I'll talk to you about it in class tomorrow. But the difference in pressure, I know that this has less pressure than this does. So if A was, I don't know, 600, if B was 660, the point is that the difference in pressure here is 440 pascals. So if you had 0 pressure here, then you should have 440 pascals here. And the difference in pressure between A and B is the same as between A and C. All right, I don't know what's up with that pesky negative. I'll talk to you more about it later. Have a good day. Bye.